JackBord bumper robot program code. In this video, we're going to learn how to make the code required to run the bumper robot. If you haven't already done so, you should watch the first video, which deals with the principles of operation of the bumper robot and its construction, and then return to this video. Bumper robot circuit. Before we get into the code, it will be helpful to look at the circuit diagram of the bumper robot. The first thing to remember is that basically we're dealing with two switches. The first switch, which is connected to port A1, is on the front bumper. So when the robot bumps into something on the front, this switch is closed. The second switch, which is connected to A2, is connected to the rear bumper. And likewise, when the robot collides with something in the rear, this switch is activated. This picture shows the overall relationship between the bumper switches and the port pins on port A. To summarize, we have two switches connected to port A. The front bumper is connected to port A pin 1, and the rear bumper is connected to port A pin 2. The common ground is connected to the ground pin on port A. Bumper robot program requirements. Before we can write a program for the robot, we need to first decide what we want the robot to do. So in this particular example, when the robot collides with something in the front and the front switch closes, two things will happen. One is the robot will go backwards or reverse away from the object that it collided with. Secondly, when it collides with an object on the front, it will do a slight turn as it backs away. This will prevent the robot from going back and forth and continually crashing into the same objects. Likewise, for the rear bumper, when the robot collides with something in the rear, it will change its direction to forwards and it will make a slight turn. The slight turn ensures that we don't keep on crashing into the same object. Now we're ready to start looking at how we're going to write the program. Writing the bumper robot program. First, log into your JackBord account and go to the Programs page on your JackBord. Load a blank program as shown in the picture. Octagon program parts. To help illustrate this program, we're going to break it down into its different parts, and the first part of all Octagon programs is the program's title. Program title. This is where you have the name of the program, followed by a brief description of what it does, and any hardware ports that need to be set up, which in our case are port pins A1 and A2. This doesn't sound very important, but 6 months from now when you want to know what the program does, this can be very helpful. Next is the variables section. This is where we tell Octagon which variables we want to use in our program. First, we declare two variables, one called front and the other one called back. These will keep a count of how many times the front and the back bumper are hit. At the end of the program, we will display the total number of hits. These are both integer variables, and Octagon knows this because there's a 0 after each declaration. Next, we have a variable called count. This is an integer variable, and its value will be increased by 1 each time the main program loop executes. This variable lets us keep track of how many times we've run the main program loop. We can use this to decide when we want the program to stop running and display the totals. All of our program variables start off with a value of 0. Program start. This is where we set up everything we're going to need for our program to be able to run. Firstly, we display the title of the program so that when we run it, we'll actually have confirmation that it's begun to run. The next thing we do is reset the buttons. This is just in case there were any buttons set from a previous run. After that, we want to set up the button press for the front bumper. To do this, we use the BTP or button press command. The format of this command is BTP, the pin name, followed by the commands that we want to have run when the button is pressed. In our program, we have many different commands, and notice that each of the commands is separated by a vertical bar. This is the daisy chain character, or pipe character, and is used to separate commands that are all on the same line. Also notice that there are no spaces at the end of a command or at the beginning of the next command. Looking at the first button press command, the first thing that happens when the front bumper is pressed is that the BMS -50 command is run. What this does is tell the JackBord to turn the drive motors so that they're going backwards at half speed. And remember, the BMS command sets the speed of both drive motors. So right now, they're both going backwards at -50. Next, we have the LMS -10 command. What this does is it sets the speed of the left-hand motor to -10. This is what causes the turn. After that, we wait 500 milliseconds with the D500 command. Then we run the LMS -50 command. What this does is set the left-hand motor's speed back to what it was before, which was -50. This will result in the robot going in a straight line. So to summarize what happens when the front bumper was pressed, first of all, we set both motors to a speed of -50, which set the robot going backwards. Next, we set the left motor speed to -10, and this starts a turn. The D500 command lets the turn continue for about half a second. And then finally, the LMS -50 command returns both motors back to the same speed so the robot goes in a straight line. After that, we increment the number of counts on the front variable so that we know how many times the front bumper has been bumped. Now that we've set up the front bumper button, we need to set up the rear bumper button. This is the button that's on A2. The BTP A2 command will set up the rear bumper button so that when the rear bumper is pressed by something colliding with it, the commands that come after the BTP A2 command will be run. The first of these is BMS 50. What this does is set both drive motors to the same speed, which is 50, and because it's a positive number, this will set a forward speed of 50. The next command is RMS 10. This causes the speed of the right-hand motor to be set to 10. Because the left-hand motor is still running at 50, this will cause a right-hand turn. Following this is the D500 command, and this will ensure that the turn continues for about half a second. Once that's done, the RMS 50 command will return each of the drive motors to the same speed, which in this case will be 50, and this will cause the robot to go forward in a straight line. And finally, we will increment the back variable, which keeps count of how many times the rear bumper has been bumped. An important thing to remember about the BTP commands is that they only need to be run once. Once they've been run, the JackBord will continually check the state of the buttons and run the commands after each press. Another thing to keep in mind is that at this point in the program, the robot is not actually moving. The next command is BMS 50, and what that does is set the speed of both motors to 50, which will get the robot to move forward at half speed. Main program loop. The next part of our program is the main program loop. It's called this because this is where the program will remain for as long as it's running. Our program loop is very simple because the button press commands actually do most of the work. The first part of our main program loop is the increment count line. What this does is it increments the value of the count variable by 1 each time the main program loop runs. Next, we need to check whether it's time for us to exit the program or not. The any statement checks the value of count, and if it is above 1000, it will run the exit program statement, or exit prog, at which point execution of the main program loop will stop, and it will jump to the prog stop task. The exit prog command is how we can exit a program while it's still running. Program stop and clean up. The prog stop task, or program stop task, is the last task run by a program in Octagon. This is always done so that when your program is finished, you can clean up and leave the robot in a safe state. For example, if your Octagon program was controlling a car and your program stopped, you wouldn't want the car to carry on down the road. In the case of our bumper robot, the first thing we do is print a message saying goodbye and telling the user how many bumps there were on the front and how many bumps there were on the back. The next thing we do is use the rstb command to clear the buttons that we set earlier. And finally, the stop command stops the robot from moving. The stop command stops the robot's motors so that when the program is finished running, the robot will stop moving. Loading the program from www.jackbord.org. Now that we've seen what the program looks like and how it works, it's time to load it into your JackBord and run it. But before you do this, make sure that you've viewed the first video for the bumper robot and that you've got all the hardware built correctly. Then, log into your JackBord account at www.jackbord.org and go to the program page. Once there, you need to select the program number that you want to load the bumper robot program into. Once there, choose the number of the program that you want to put your bumper program into and click Load. The program will be loaded into that slot. Then, we need to find the bumper robot program on the JackBord website. You do this by clicking on the Reference tab on the right-hand side of the program page. This will bring up the program page's main help page. At the search prompt, enter the word bumper and click the magnifying glass. In the results, you will see an entry called Bumper Robot Program. Click on this result. This will bring up the Octagon program listing for the bumper robot. Next, we need to send this program to your JackBord. To do this, first of all enter your JackBord's ID at the prompt. Then select the program number where you want the program to be sent. Make sure it's the same as the one you chose earlier. And finally, click the Send button. You'll be asked to confirm your choice and click OK. Wait about 10 seconds to give the program a chance to arrive, and then click on the Load button on the top left-hand side of the program page. The bumper robot program should be loaded into your program window on the left. Your program window should look like this. Now we need to run the program. To do this, at the top left of the program page, click on the Jet Aeroplane. This will run your program. When you run the program, you should see print output similar to that shown. The program will run for about 15 seconds and then stop and display the number of front and rear bumps. Congratulations! You've now built your first bumper robot.